Okay, so in this video, we're going to be looking at how to write equations of a line that are parallel or perpendicular to a given line and passing through a specific point. Now, in this case, we're going to pass both of our examples through the point 4, -3. And so we're going to start with the parallel line. So for the parallel line, we need to find the slope of the line because it's the slope of the line that's going to be repeated when we create the slope of the new line. So let's solve for y. So that's going to give us -2y is equal to -3x plus 10. And then I'm going to divide by -2. And that's going to give me 3/2 x minus 5. So double checking my math, I think that's good. All right, so that means m is equal to 3/2 for the parallel line. And so I'm just going to put a little note here in the subscript that this is for the parallel slope. So parallel lines have the same slope. And so we're going to use the point slope form of the equation, and then we'll solve for y equals mx plus b. So I'm going to have y minus a -3 is equal to 3/2 x minus 4. And then if I simplify, y plus 3 is equal to, let's distribute my 3/2, 3/2 x minus, well, the 2 and the 4 are going to partially cancel and leave me with a 6. And then if I subtract 3 from both sides, y is equal to 3/2 x minus 9. So that is my equation of the line that is parallel to the original line, but passes through the point 4, 3. If I wanted to, I could put this in standard form. That would give me -3/2 x plus y is equal to -9. And if I want to clear the fractions, I can multiply everything by -2 to get rid of the leading negative signs in math. Math people tend not to like that. So multiply everything by -2, we get 3x minus 2y is equal to 18. Now, notice that the 3x minus 2y, is the same thing as we had for our original standard form of the line. The thing that has changed is the constant. All right, now, if I want to do the perpendicular slope, there's a couple different ways that we can express this relationship. So m perpendicular we can think of it as the negative reciprocal of the original slope. So we would flip the fraction and change the sign. Another way to think about this is that the product of the two slopes is equal to -1, but this is really just a different way of saying the same thing. So our parallel slope, the slope of the original line, was 3/2. So m perpendicular is going to be -2/3. So again, flip the fraction and change the sign. And so now we go and we build our equation going through the same point. Y minus -3 is equal to -2/3 x minus 4. We're going to have fractions here that aren't going to clear nicely, so be a little bit more work. If I distribute my -2/3, I'm going to get -2/3 x plus 8/3. So negative times a negative gives me a positive, and 2 times 4 gives me 8. Again, nothing cancels here. And then I'm going to subtract 3 from both sides. 8 divided by 3 minus 3 is going to give me negative 1/3, since 9/3 is 3. So 8/3 minus 9/3 is going to give me negative 1/3. That is my slope-intercept form. And then, of course, in standard form, I can put everything on one side of the equation. And then if I want to, I can also clear my fractions. 2x plus 3y is equal to negative 1. Now, one thing you may notice about the perpendicular line is that in my original line, I had 3 minus 2y, and here I have 2 plus 3y. So not only did the coefficients of x and y flip, but also the sign changed. Now, again, we have no way of getting the constant without actually going through this whole process, but that is something that you can sort of think about as you're trying to do these problems to make sure that the answers that you get make sense and that they're consistent with what we would expect. Now, just to deal very briefly with the special cases, if the original line is horizontal, i.e. y equals some number, let's call it little b, then the parallel line is y equals whatever the y coordinate of the point is. So in our case, that would be negative 3 to go through the point for negative 3. The perpendicular line would be x equals whatever the x coordinate is, which in our case would be 4. If the original line is vertical, x equals a, then the parallel line is x equals, in this case, 4, and the perpendicular line is y equals, again, going through whatever coordinate of our point is. So it's just keep in mind, horizontal and vertical are perpendicular to each other. This equation that we talked about for the perpendicular slope, the parallel slope, if it's horizontal, will be 0. And then if you take the reciprocal, you get undefined. What equation has an undefined slope? It's a vertical line. Same thing if you start out with the vertical line. The original slope is undefined. How can you take the negative reciprocal of that? So, well, these relationships are, they do somewhat fit the general model. There are some arithmetic problems when you're dealing with vertical and horizontal lines and making them parallel or perpendicular. So it may just be worth remembering that horizontal lines, y equals whatever, don't necessarily go through the whole slope process. Just keep in mind, the equation will have the same form, y equals whatever, but you just have to pass it through the point that is given to you. And the perpendicular one will be the opposite. Simple, again, simple special case line. If you start with y, perpendicular will be x. If you start with x, perpendicular will be y.